Welcome to another exciting mathematics video, and this video is brought to you by Vision Concept Academy. We'll be looking at past questions in JAMB exams, and our focus is still on 2010 exam. I made the first video where we solved from question 1 to 17, so we'll follow up with the video from question 18. If you are new to this channel, please subscribe to our channel so you can get more exciting videos, more educative videos from Vision Concept Academy. And if you are here, you've been here before, you can make a comment on our teachings, ask questions, and hit the like button to support the channel. So the question right in front of us is, if x is inversely proportional to y and x is 1/2 when y is equals to 2, find x if y is equals to 4. Now this is still under inverse proportionality. The formula is x is inversely proportional to y. This is the formula. When you introduce the constant sign, the constant k, this inverse sign turns to equals to, and you have k constant times 1/y. Now, our goal is to find what k is with this relationship for the first instance. That is when x is half and y is 2. So, the formula again is x times y is equals to k. That's, we just made k subject of formula. So we're going to have the first instance when x is equals to half. Half is what? 2 times 1, 2 plus 1, 5. That's when x is 5/2 and y is 2. What is k? What is k? So k is equals to x, which is 5/2 times y, which is 2. And k is equals to 5. So the constant is 5. So whatever the value of x and y that comes, the constant 5 must be there. So to find x when y is 4, the relationship again is x is equals to k/y. That's this one. This one is the same thing. So we know that k is always 5 from what I've gotten from the first relationship. Now, the second relationship now is that when y is 2, find x. Find this x when y is 4. So I said x is equals to, k is already 5 and y is 4. So x is equals to 5/4. So that's the answer for this one. X is equals to 5/4. No matter, I think in the options, they express that decimal. So x is equals to 1.25 by the time you divide. That's the answer. Okay. So we'll go to question 19. Question 19, I will write it on the board. Question 19. Okay. Question 19 says, for what range of values of x, number 19, for what range of values of x is 1/2 x plus 4 plus 1/4 greater than 1/5x plus 1/2. So for what range of values? This is under the topic inequalities. We will check out our videos for this topic. That is why I say you should subscribe if you are new to the channel, so that you can see where we did all this step by step. So this is inequality. This is inequality. So for what range of values is x this? You understand? So it's like as if we're going to be solving a linear equation where this inequality sign is seen as an equal sign as an instance. You are going to solve it just taking it as if this is an equal sign, and apply linear equation technique to solve. Just that the sign will be changing depending on whether there's a minus. We'll talk about it when we get to the point. So at this point, you will just collect like terms, collect like terms, collect like terms, just like as we do in a linear equation. So we collect like terms, collect like terms. Okay, so I have a term here that has x, that's half x, and I have a term here that has x, that is 1 over 5x. So when it crosses, it becomes 1 over 2x minus 1 over 5x. Then this is still like this. So this is half. When this one crosses, it becomes minus 1 over 4. Minus 1 over 4. Okay, so we're going to quickly look for LCM relationship. LCM relationship. This is, I'm going to solve this fractional case. 2 and 5 are the denominators at this side. I'll just roll my line. The LCM of 2 and 5 is 10. 2, how do I get 10? How do I get 10? Just because you don't have any common factor, multiply these two. Multiply these two. So I have 10. So 2 into 10 is 5 times. 5 times 1 is 5. X, yes, minus 5 into 10 is 2 times. 2 times 1 is 2x. Still, this sign is greater than. So I rule line to resolve this. The LCM of 2 and 4 is 4. 2 into 4 is 2 times. 2 times 1 is 2. Minus 4 into 4 is 1 time. 1 times 1 is 1. So at this point, I can solve the numerator. This is 5x minus 2x. 5x minus 2x. Okay, hold up. Okay, so the question, I didn't copy the question very well. It's not supposed to be 5, it's supposed to be 3. Please, the question, if we to go to the question in JAMB, the question there is 1 over 3, please. So if this is coming here, it's 1 over 3, 1 over 3. And this one, the LCM of 2 and 3 is 6. So 6. So 2 into 3, 6 is how many times? 3 times. 3 times 1 is 3. So 3 into 6 is 2 times. 2 times 1 is 3 into 6 times 2 times 1 is 2. Okay, so that one is correct. And this one is also correct. Okay, so we continue from there. So 3x minus 2x is x over 6 greater than 2 minus 1 is 1 over 4. So at this point, I can now take, this one will now go up, or I can now say multiply both sides by 6. So it's now, let me come here, multiply both sides by 6. Multiply both sides by 6. So this part times 6, and this other part times 6. So 6 cancels 6. X is greater than 6 over 4. X greater than 3 over 2 when you reduce to the lowest term. So this is the answer for this question. So for what range of values of x is this? You understand? It is x greater than 3 over 2. So if I put 3 over 2 in this equation, you understand? You see that this side greater than this side. Yes. All right. Okay, so we'll still go further. There's another question on inequalities here that we'll consider. Okay, so question 20 says solve the inequality. So you see, in our page, I shared the likely areas where you get questions. So you see that inequalities is part of what we should be looking at. Okay, so minus 6 less than or equal to 4 minus 2x. Okay, another one, less than 5 minus x. Okay, so let me confirm the question again. Minus 6 is less than or equal to 4 minus 2x less than 5 minus x. Okay. So the first thing we'll do for this one, we are going to be solving it in components. Let me write the question out again. Minus 6 less than or equal to 4 minus 2x less than 5 minus x. So there are two components. This is the first component, and this is the second component. So I'm going to solve this and solve this and this. I'm going to solve them individually. That's bit by bit. So I'll bring out first inequality. First inequality. So it is this one. I'm writing it out. Minus 6 less than or equal to 4 minus 2x. So for this one, I will just quickly collect like terms. If 4 goes to this side, it becomes minus 6 minus 4. Still less than or equal to minus 2x. Okay. Now, by the time I do this, okay, hold up. Okay. So by the time I do this, it now becomes minus 10 less than or equal to minus 2x. So I have divide both sides by minus 2. Now, if you are dividing both sides, if there's a minus sign dividing both sides, this inequality will reverse. Understand? So I have minus 10 over minus 2. Because this minus is coming under here, this one will reverse this way. So I have x. Understand? So by the time I have it now, I have 5 greater than or equal to x. So that's the first inequality. Now for the second inequality, you see, I've solved for this one. I'm going to solve for this one. It is 4 minus 2x less than or less than not equal to less than 5 minus x. Okay, so again, we'll collect like terms. So this is 4 here. 5 will go minus 5, equality sign, inequality here. Then minus x is here. Then minus, this minus crossing becomes plus 2x. Plus 2x. Okay, plus 2x. So what do? We just do the math. This is minus 1 less than this and this will become x. So because we are dividing both sides, by minus, this inequality will reverse. So I have it as minus 1, then it will be taken to this side, then x. So I have two solutions. I can marry them in one straight line. So this one is minus 1 less than x and less than or equal to 5. Okay, so that's the answer. So we're going to go to the next question. We're going to go to the next question. Question 24. We just finished question 20, so question 21. So it says, find the sum to infinity. Find the sum to infinity of the following series. So this is the series. This is the series 0.5 plus 0.05 plus 0.005 plus 0.0005 and so on and so on. It continues. It continues. Okay, so that's the series on the board. That's the series on the board. First of all, what kind of series is this? What kind of series is this? If I look at the terms, this is the first term, second term, third term, fourth term, and so on. What is the relationship between the first and second term? That relationship will determine what kind of series this is, either geometric progression or arithmetic progression. From if I say 0.05 divided by 0.5, you understand? The ratio is 0.1. And if I now say 0.005 over 0.05, the relationship is 0.1. 0.1. So at this point, because the division of a term by the preceding term is a constant, this series is a geometric progression. So we're going to treat that short. There's a formula for it. This is a geometric progression. This is a geometric progression. Geometric progression. Please check out our video on geometric progressions. We discussed, or we said that if you have a series where dividing a term by the preceding term will give you a constant number, that progression, that series is geometric. And by the time I divide this by this, if I get a constant term and I still do this by this, I get another. Saying dividing this by this, I get one term. This by this, I get the same term. This by this, I get the same number. That series is a geometric progression. Well, we just proved it here. By dividing this by this, we saw this as the answer. We divide this by this, we are seeing this as the answer. Divide this one by this one, you still get this one. So that's geometric progression. So another thing again we saw is that for geometric progression, the sum to infinity is a over 1 minus r. A over 1 minus r. That's the formula. Now we are given here that a is 0.5 and r is 0.1. So we can find the sum to infinity by substitution. Sum to infinity is equals to a 0.5 over 1 minus r 0.1. 0.5 over 1 minus 0.1 is 0.9. So sum to infinity is equals to 5 over 9. So that's one of the options that we have there. Okay, so that's question 21. Okay, so let's progress. Progress. Okay. All right, so we have another question here. It says, this number 22. Yeah, 22. It says the third term of an arithmetic progression. See this one now, it has been defined. Arithmetic progression is minus 9. And the seventh term is minus 29. Find the 10th term. Find the third term of the progression. Okay, so the third term of an AP, we also saw there's a video too for arithmetic progression. Please check out the video from the Academy. Kindly subscribe if you have not done so. Please subscribe. subscribe so that you can be seeing all these videos. We have done all these videos. We have done explanation. What we are doing now in this particular video now is to solve past questions. And as we are solving it, you see that we have treated it before. We have treated it before, the foundation of each of these topics. Please do well to subscribe. All right. So the third term of an arithmetic progression is -9. So how do we get the term, nth term? Formula for nth term. Nth term of arithmetic progression. Nth term of an AP is equals to a plus n minus 1 then d. That is a plus open bracket n minus 1 close bracket then d, where a is the first term, n is the number of term, and d is the common difference. So for the third term, let me call T3. Let's call it T3. The third term is -9. And the seventh term, T7, is -29. You know T3 has its own formula. You can write it. T3 formula is like this. T3 is equals to a plus n for T3 is 3. N is 3 because number of term in that 3 term is 3. -1, then d. So the formula T3 is equals to a plus, this 3 minus 1 is 2d. So this formula for the third term, you understand? And we're given third term already as -9 is equals to a plus 2d. This is an equation that has two variables, a and d. Let's call this equation 1. Also, T7 has its own formula. T7 is equals to a plus open bracket n for 7. T7 is 7 minus 1, then close bracket d. And T7 is given as -29. -29 is equals to a plus 7 minus 1 is 6, then d. This T7 here has two variables, a and d. Let's call it equation 2. At this point, we're told to find the 10th term. To find the 10th term, we need to know what a is in this progression and d is in this progression. Okay, so what is a in this progression? We are solving simultaneously. So we have two equations, equation 1 and 2. So I'll rule my line like this. I will now say from 1, make a subject. From 1, this 1 means equation 1. Make a subject. Make a subject. That's make a to stand alone. So let our eyes be on this our equation 1. Our eyes is there. So if a want to be subject, this one will go and join -9. So I will just put a. A is now the baba, the subject. Then -9. Then this one goes -2d. So I've made a the subject. I've made a the subject. The next thing I will now do is to put this one in equation 2. Substitute in equation 2. Okay, so equation 2 here says -29 is equals to, where I see a, I put what I have here, -9 to 2d plus 6d. So -29 is equals to, then I open this bracket, -9 minus 2d plus 6d. So I collect like terms. This one will go over. -29. When this one goes over, it becomes +9. Is equals to -2d plus 6d is 4d. This is 4d. This is 4d. When this one is 4d, -29 plus 9 is -20. Is equals to 4d. So I'll divide both sides by 4. So I have my -20 over 4 is equals to d. And d here will be -5. So I've gotten two things here. I've gotten a as what? We have not gotten a. We have just gotten d. Oh, we have just gotten d. So d is -5. So to get a, what do we do? Where is a? We will put it here. Let me take this one off, this side. Let me take this one off. At least this one, you understand this point. So I'll take this one off. So we are gotten d as -5. So we will now put d into this equation. A is equals to -9 minus 2. When we see d, I'll put minus 5. Yes, minus 5. So A is equals to minus 9. Then minus 2 times minus 5 is plus 10. So A is equals to 1. So A is 1. Therefore, A is equals to 1 and D is equals to minus 5. So these are the two things in this term. But our concern, our goal is to find the 10th term. So T10 has its own formula, A plus N minus 1 D. This is the formula for T10, where N inside T10 is 10. So T10 is equals to A of the 10 of the series is 1 plus N is 10 minus 1, then D is minus 5. So T10 is equals to 1 plus 10 minus 1 is 9 times minus 5. So T10 is equals to 1 plus 9 times minus 5 is minus 45. Minus 45. So T10 is equals to minus 44. That's the 10th term of that series, minus 44. Okay, so that's the answer for that question. So we'll go to question 23. Question 23. Okay, so this one is binary operation. 23 says, if x, there is an operation here that's like star. If x star is equals to x plus y squared, find the value. Find the value of 2 star 3 star 5. Okay, so this topic is what we call the binary operation. Please, at this point, if you're not subscribed to our channel, subscribe to our channel. Click on the subscribe icon and subscribe. Also turn on the notification bell so that when we release a video, you will see it. Binary operation is treated in our channel. So look for that video and see how we came about those operations. Okay, now, but for this one now, the question says x star. You know, we said mathematical operations are basic operations. You have plus, times, minus, division here. These are operations. So we know what plus can do. If you put two numbers like this and put plus in their center, you know what to do to get the answer. At least we have done it in our nursery schools. If you put 2 and 3, you now put this operation at the center. You know what to do now to get the answer. So we're not going to all those ones because we are all going to primary, secondary, and nursery school. But sometimes you get operations defined like anything. It could be any shape. Asterisks. You can even have a triangle. You can have a rectangle. They just put something for you to say like there's an operation that is binding, that's going to be working on these two numbers. But then they will define it for you what the operation is doing. So this star here, if you collect these two terms like this, these two terms, this star is this thing. Carry out this thing on these two terms. That's what you are being told to do. You understand? Okay. Now, if we want to do this, first of all, we will take these two and compute it based on this, because it has been defined. See, this looks like this. This one looks like this now. This is star x star y, 2 star 3. It's the same thing, just that x in this case is 2, y in this case is 3. So when you now use this what is done here to define this one. So first, compute the first one. First, compute for 2 star 3. So 2 star 3 is defined like this. So where x is what? Let me just define where x is equals to 2, and y is equals to 3. So put it here. Run it then. So I put 2 plus this one is what? 3 raised to the power 2. Is it not? So 2 plus 3 raised to the power 2. 3 raised to the power 2 is 9. 2 plus 9 is what? 11. So I've gotten this one. So I can rewrite this like this. So this first one has been operated on. 11 star 5. So my new x is equals to what? 11, and my y is equals to 5. So I will run the operation again. So I will now run it. X plus y squared. So 11 plus 5 squared. 11 plus 25 is 36. So the answer for all these things is 36. This thing is really not difficult. It's just for you to just know, just the operation has been defined like this. You understand? So take which one is x, choose it concurrently. This is x and this is y. By the time you get anything here, the next one again, the two of it resolved is x and this one is y. No matter how complex it is, first of all, define your terms by what you have there. Okay, so we're going to question 23 or 24. Okay, 24. So if you have the question we are sampling is 2010 math JAMB question, we are going to do all start from there and be solving the question 2010, 2011, 2012 until we get to where we have before the JAMB will start, the exam will start. So we are sampling from 2010 and we're going down. You know, JAMB normally repeat question, or the topics are similar. Even if they don't repeat it, they just change one or two terms. Okay, so for this one, number 24, it says if P and Q are two non-zero numbers, and 18 open bracket P plus Q is equals to 18 plus P. 18 plus P then Q outside. Which of the following must be true? Which of the following must be true? I'm going, because it's essentially following, I'm going to put the options the way it is. Then I say option A is Q is equals to 18. Option B is P is equals to 18. Option C is P is less than 1. Then option D is Q is less than 1. Okay, so these are the options that they put there. Okay. All right. So I'm putting the option there because it's actually the following. Now, we are given an equation. So given this equation, let me put it on the board. Given that 18 open bracket P plus Q is equals to 18 plus P, then all close bracket then Q. So we're going to expand, first of all, expand. Now look at the question. It said, for which of the, if P and Q are two non-zero numbers, so they are not supposed to be zero. Note this in that they put this here for a purpose of non-zero, they put it for a purpose, but not be zero. Okay. All right, so expand first. Expand. So expand means just multiplying. 18 times P is 18P. plus 18 times Q is 18Q is equals to Q times 18 is 18Q plus P times Q. Q times P is PQ. Now, having done that, we can collect like terms. We can collect like terms. Or collecting like terms. This one, 18 is here, they can cancel. Let me just do it that way. 18P plus 18Q. When some crosses come minus 18Q, and some crosses come minus PQ is equals to 0. So this and this are gone. So I have 18P minus PQ is equals to 0. What's common in these two? P is common, so P will come outside. And what is left is 18 minus Q is equals to 0. You see, this is just factorization. 18, that is 18 and P, they are factors, they are multiplying themselves. And here, P and Q. So if I remove this P and bring it out, and see remove this P and bring it, because it's the same P. There's a P, there's a P. If I bring out one of it, and the other one will not be there again now because one has come out. So what is left now is 18 and Q. That's why we have it like this. So either P is equals to 0 or 18 minus Q is equals to 0. Whenever it's something like this, it means that P is multiplying 18 minus Q. That's these two are multiplying themselves. So for this equation to happen, to be 0, one of them has to be 0. If, for instance, I have 2 times, okay, I have A times B is equals to 0. For this equation, for this thing to be correct, either A will be equals to 0 or B will be equals to 0. One of them has to be equals to 0. One of them. So that if A is 5, that means B will be 0 for this answer to be 0. Or if B is 6, that means A has to be 0 for this. So one of them has to be 0. That's why we have it like this. Either P is equals to 0 or 18 minus Q is equals to 0. But then we're told that there are two non-zeros. That means this one solution is not valid. It's not valid. So we are now left with this one. Therefore, I can come here. Therefore, 18 minus Q is equals to 0. Then Q will go to the other side. 18 is equals to Q. So Q is equals to 18. That's the answer. That should be A. A is the option. That's A is the option. Okay. Let's progress to number 25. Number 25. It says if x 2, 3, 7 is equals to 15. Find the value of x. Find the value of x. So at this point, if you're not subscribed to our channel, please subscribe to our channel for more exciting videos. You'll be seeing videos that these kind of things are solved or these kind of things are explained. This is actually matrices. This is a 2 by 2 matrices. See, 2 by 2 matrix. 2. That's this 1, 2 is the row. Yes, and 1, 2 is the column. So this is 2 by 2 matrix. And this is equals to 15. The determinant is equal to 15 there. So find x. So the way matrix works is that to find its determinant, you multiply this by this minus this by this to give this. Okay, I go again. Let's say, if we have a matrix like this, A, B, C, D, small letter D, the determinant is equals to A times D, is equals to, is minus B times C. That is this one this times this minus this times this, that's the determinant. So for this one now, they are giving determinant as 15, but they say you should find what x is. So just apply that principle. X times 7 is 7x, minus 2 times 3 is 6. Is equals to 15. This is the equation. It's a linear equation. So minus 6 goes over to meet 15. 7x is equals to 15. When it crosses over, it becomes plus 6. So 7x is equals to 15 plus 6 is 21. X is equals to 21 over 7. X is equals to 3. So 3 is supposed to be here to make that determinant true. Okay. So let's progress. Let's progress. We have number 26. Number 26. 26. So they now graciously gave us a 3 by 3 matrix in the next question. So I'm using style to, but you can still subscribe or subscribe to our video to get the full explanation of all this from the beginning, from how, from the foundation. We're just solving it, knowing that you have already gone through that. So subscribe. Subscribe. This is 4. I need to see clearly. This is 8. Yes. 8, 1, 6, 9, 2, 3, 1, 7. So find the determinant. So this is a 3 by 3 matrix. 3 by 3 matrix. A matrix, see, R row, R row and column V. So R H is horizontal, C V vertical. Arrow is row, C is column. Arrow horizontal. So these are the rows. These are the rows. R1, R2, R3. These are the rows. Row 1, row 2, row 3. Column is vertical. Column 1, column 2, column 3. I'm just trying to let's refresh your memory. When this is not the part of the question, but I'm just explaining that this one now is column. Row 1, column 1 is 4. Row 2, column 1 is 8. Row 3, column 1 is 1. You understand? So this is how it is. So row and column. But this is a 3 by 3 matrix. 3 by 3 matrix. So say find the determinant. So the determinant actually is given by expanding using this one. That's, I will pick this first one here and use this one as determinant. So I'll put 4 outside, multiply into a 2 by 2 matrix that has been reduced like this. See what I've done? So this 4 actually is multiplying everything inside, is it not? Yes. The next one again, this one now, let me remove this one I've done. So you can just follow, it's a video, follow. You can pause it, you can, anyway, you don't understand. I've done for this first one. So after this first one is a plus, minus, then plus. Second one now is minus. I'm looking at 6, so I take 6 like this, and I take this and this as a 2 by 2 matrix. So 6 outside, 8, 1, 1, 7. I close it. I'm done with the center one. So I will free it. Just free it like this. Just it's demonstration I'm doing. When you are used to it, you will not need to be doing what I'm doing. Okay, so the next one is plus 3. Plus 3. So I take this plus 3 and I take this one as determinant. So I come here, 8, 1, 9, 2. So I can erase. So you see what I've done? I have resolved this 3 by 3 into series of 2 by 2, having something to multiply the determinant of the 3 terms. So there's the first term, this is the first term here. The first term is gotten by, I take the first number here. In fact, it's this number that I'm working with as the number that is multiplying the determinant. This one, and this one. If I take this one, I'm going to be working on this determinant, 2 by 2. If I take this one, I'm going to work on this and this. That is, I'm trying to, I'll be avoiding anything that has to, that will cross this one. That's either way. I've chosen 6. I will avoid anything that cross here and cross here. I will avoid any element. You understand? I will only work on the outside element. That's what I've done here. So for this one, when I take this one now, plus 3, you understand? I'm avoiding anything that is here. I'm working on, so that's why I have this one like this. Okay, so from here, 4 is outside. The determinant of this one is 9 times 7. 9 times 7 is what? 56. Okay, let me just put it like this. 9 times 7 minus 2 times 1. Then minus 6, open bracket. 8 times 7 minus 1 times 1. Then plus 3. 8 times 2 minus 1 times 9. Okay. Okay, so we'll do it gradually. Okay, so 4 is outside still. 4 times 9. Sorry, not 4 times 9. 9 times 7. Or 7 times 9 is 63. Minus 2. That's for this first one. Then minus 6. 8 times 7 is 56. 8 times 7 is 56. Minus 1. Then plus 3. 8 times 2 is 16. Minus 9. Okay, so still 4 outside. This is what? 61. Minus 6 outside. This is 55. Plus 3 outside. Then that is 7. So this is a simple math. 4 times 61 is 244. Minus 6 times 55 is 330. Plus 3 times 7 is 21. Please, also when you are doing your practice in mathematics, be very good with your algebra, your addition, subtraction. Use your calculator when you are not sure, when you are not, just use your calculator for big things like this. Okay, so at this point, by the time you resolve this one, your final answer will be minus 65. Okay, so this is a 3 by 3 matrix. Then this question, this 2010, they now finished the matrices by giving us the next topic, inverse of operation, number 27. So I'm going to be finding the inverse. The inverse. So let me just quickly put the question on the board. So they have covered matrices for this year. 27. It says if P is equals to, so they put a matrix here, 2, 1, minus 3, and 1. What is P minus 1? This P minus 1 means inverse. What's the inverse? What's the inverse? Okay, so for matrices, the inverse of a matrix is given like this. So if you have, for instance, if you have a, let's say for instance, if you have a matrix, let's say if you have a matrix like this, A, you have B, you have C, you have D. Equation of matrix. Therefore, inverse is how it is. Inverse of the matrix is given as this matrix. Maybe let's say Y. We define as this. So Y inverse is given as 1 over the determinant. 1 over the determinant. Open bracket. You have this and this. I want to explain it very well. This will go, this and this will invert. So D will go where A is, and A will go where D is, first of all. Y, B, and C will take minus sign. That's what this inverse is all about. That's what it's all about. So first of all, when you want to get the inverse of this, find the determinant. That determinant, this determinant, this symbol is determinant. Find the determinant. Then you take it as 1 over that determinant outside. Then multiply it by this kind of arrangement. Okay, let's do it. Let's do it. Look at it here. So first of all, determinant of P is 2 times 1, 2, 2 times 1, 2, minus 3 times minus 1. Sorry, minus 3 times 1 is minus 3. So the determinant here is 2 minus 3 is equals to 5. So determinant is 5. That one is gotten. So let me say delta P is equals to 5. The determinant has been gotten. Now, to find the inverse matrix inside here now, like I said, this one now will go down, this one will go up. Why these two? We just take minus sign. So therefore, P inverse is equals to 1 over determinant P, which is 5. Then I open my brackets. I swap these two. 1 will go up and 2 will come down. Then this one will come minus 3, and this one will come minus 1. This is how it is. So I'm going to find the inverse now. Inverse is equals to, well, I've gotten determinant as 5 now. So 1 over 5. Then open my brackets. Then I will just quickly do the matrix. 1 times 2 is 2. Then minus, this one is already plus 3, because minus, this is plus 3 already. Plus 3 times minus 1 is still minus 3. Okay, we're not finding the, sorry, sorry, at this point, we're getting the answer now. No need to go do this long way. At this point, we're getting the answer. See where we are. Just put this one like this. We're not looking for the overall determinant. We're looking for just the inverse of the matrix. So this is it. 1 minus 1. This one will come plus 3 and 2. This is it. This is the answer. This is the inverse of the matrix. We have just inversed it. We're not doing determinants again. We have just reversed it. So this is the inverse. But we can now multiply this one by each of the terms here. So see the answer here. So 1 over 5 times 1, that's this first term here, becomes 1 over 5. Then this one too, minus 1 over 5. Then this one, 3 over 5 and 2 over 5. These are just the elements of inside this matrix. So we'll just multiply this one. This one will multiply this determinant, this element here. 1 over 5 times 1 will give 1 over 5. That's the element there. Then this one times this one will give you this. This one times this one will give you this. And this one times this one will give you this. So that's what we need to do. So this is the inverse matrix of the whole of this. Just get the determinant first. When you get the determinant, 1 over determinant, then swap the positions. Swap this one goes up, this one comes down, then this one takes minus, this one takes minus at the same time. All right. So we go on to the next one. Okay, number 29. We skip 28. Why? Because the question is, there's a missing parameter in the question. It has to do with cyclic quadrilateral. So that one is confirmed. There's a missing parameter there. It's supposed to be a bonus question for JAMB. Number 29. So let's start number 29. Number 29. Okay. So it says, if interior angles of a quadrilateral are 120 degree, sorry, 120 degree, comma, x plus 15 degree, that's all it's a component degree, comma, 2x minus 45 degree, comma, x plus 10 degree. Find the value of x. Find the value of x. Okay, find the value of the least. Find the value of the least interior angle. Least interior angle. Okay, this one is understandable now. So a quadrilateral is a four-sided shape. But they didn't say it's cyclic, but anyhow, if it's something like this, you understand? So let's say this one is 120, this one is x plus 15. This one is 2x minus 45. This one is x plus 10. So it's a four-sided shape. Quadrilateral is four-sided. If it's triangle, you have triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. So it is by the name of the shape. So triangle, tri is 3. Quadrilateral, quad is 4. You understand? Then pentagon is 5 sides. You understand? So you have pentagon, you have a hexagon, which is 6, and so on. Hept. Then octagon is 8, nonagon is 9, and decagon is 10. So this is quadrilateral 4. And the sum of interior angles in the quadrilateral shape, sum of interior means inside like this, inside. So the sum of interior angles is equals to 360 degrees. So sum, if you add everything, so let's add 2x minus 45, that's this first angle, plus x plus 10 degree plus x plus 15 degree plus 120, all will give us 360. That's the sum of all the angles. Let us find what x is. The question says we should find the least value of interior. So which of them, this one is 120, it's already known, but which of them, by the time I put what x is and compute everything, which of them is the smallest angle? That's what they're asking us to do. But first of all, I've gotten the first equation where we say that the sum of interior angles in a quadrilateral is equal to 360 degrees. So I've added them together. So I'm going to just do it. Just remove my mind from all this degree because it's the same thing, this degree. Just remove your mind from degree. Just work on the numerals and the variables. So 2x minus 45 plus x plus 10 plus x plus 15 plus 120 is equals to 360. Don't be afraid of all this number of tens. First of all, know that, just know how many. See, 1, 2, 3, 4, 5, 6, 7, 8. So that by the time you go to the next line, don't go and write, I can't only 7 terms. So collect like terms. So 2x will stand here, Gidiba. Carry this one and join it, plus x. Carry this one and join it, plus x again. Any other x again? No. How many x do you have? 1, 2, 3 x terms. So put the equality sign and write this one here. Carry every other constant term to go to the other side. Start from here. Minus 45. When it crosses over, it becomes plus. The next one is 10. When it crosses over, it becomes minus 10. 15. When it crosses over, it becomes minus 15. 120. When it crosses over, it becomes minus 120. Okay, so let's add them together. This is 4. 2x plus 3x is 2x plus x is 3x. 3x plus x is 4x. It's equals to, at this point, by the time you put your calculator, what you have here is 260. When you do the math, do all this math. 360 minus 4 plus 45 minus 10 minus everything here is what? 260. Okay, so divide both sides by x by 4. X is equals to 260 over 4. Therefore, x is equals to 65 degrees. Now, if x is 65 degrees, what is the least interior angle? So that means I know that the first angle that has number there is 120. Number 1. The second one, number 2. X plus 15. If I put this in here, what I have is 65 plus 15. Do the math. 5 plus 5 is 10. Carry 1. 7 plus 1, 8. That's 80. Third angle, 2x minus 45. So 2 into 65 minus 45. So this and this is 130 minus 45. 130 minus 45. Okay, what do I have? 130 minus 45. Okay, this is already 30, that's 85. This is 85. This is 85. Okay. Yeah, this is 85. Then the fourth angle, 65 plus 10. That's x plus 10. That's 75. So which one is the smallest? 75, 85. So 75 is the smallest angle. That is this one. That's that one. So we're going to stop here for today. I hope this video has been informative for you. I'd like to thank you for viewing.